Okay, picking up from where we left off with the introduction to DFMPro, here we now have the results of the findings that were associated to this demonstration part that we use with DFMPro to highlight some of the capabilities that the system has in terms of being able to find manufacturability issues. And so as you can see here on the left-hand side, the top left here under DFMPro in CREO, we have our start menu, and then we have some other buttons that are available to us here. And we'll go through those first. Basically, we have the real-time button. Real-time works in the fashion that allows us to look at things like injection molding, additive manufacturing, sheet metal, and prismatic mill. And there are several rules that are associated to each one of these manufacturing process types that DFMPro will utilize in real-time mode. So as you're working, DFMPro will actually go through and depending upon what type of feature you're adding or operation you're running through with your system, DFMPro will take and run an analysis instantly in real-time mode. And so this is a real-time interface here, and that can be turned on or it can be turned off, and we can cancel it. But we'll cancel it for now. So now that we have the DFMPro analysis data running here, we can start to take a look at some of the other things. The rule manager. I did show the rule manager before and kind of gave us a highlight of what the rule manager does. The rule manager is basically the nuts and bolts of the system, meaning it has the information in it pertaining to the actual rules. And so let's take a look at some of the rules here. We'll go in and take a look at one, for instance, called deep narrow slots. And you'll notice what I did. I came over here and double clicked on it and it opened up the window. I can also right mouse click on it and say configure rule. And this is what we call it, configuration. We can configure the rules and we can put values in the rules and work and associate with the specific rule. And in this case, the rule is kind of self-explanatory in its name, narrow slots, for this one. And essentially what that allows us to do is it allows us to go in and define what the parameters are for a narrow slot. And if we have those parameters set up, then DFMPro will run through the analysis phase and highlight anything that is outside of the bounds of the parameters in association with the specific rule and what the rule is supposed to be doing. And so that's an explanation of the rule. You'll notice one thing that I did here is I went up to this question mark and opened the question mark up, which gave me access to our documentation. Each and every rule that's associated to DFMPro in the rule manager and that is used in DFMPro has an associated help file. That help file information has the rule definition, what the rule is doing. It explains the rule. It gives the recommendations for usage of the rule. It talks about the configuration, and we even provide some simple pictures for those. And then, of course, we have the parameters that are associated with the rule, if there are parameters. And in most cases, 99% of the time, there will be parameters associated to that. And so DFMPro gives you the access to that. And then it gives you information about specific things like operators, greater than or greater than or equal to the value for the slot. And so cross-section area of the pocket slot to depth ratio. And so it's a set of parameters that are used to configure. And you can see I can highlight those parameters and I can change those parameters. And those parameters then get stored inside of the rule manager itself. And in the cases where there is extra data or lots of data, like for instance, materials or fasteners or parts, then there is a back-end database that's associated to DFMPro as well. And one of the other things that we can do is we can assign a criticality. So we have the critical, high, medium, low, and insignificant. Now, the criticality is important because it helps us understand, it helps customers understand those things that are supercritical are probably going to trigger an engineering change notice. So if you've released something into from design into production, and then we ran DFMPro on it, and DFMPro flagged something that had a critical aspect to it, there is a possibility that that criticality could cause it to have to go back into design, meaning that there is a manufacturability issue downstream. And so that's basically how the rule manager works. We'll get into a little bit more of that later, in terms of the rules themselves, but you'll notice that there are categories. I can sort by these categories. And anything that is sorted can be activated as well. And so with the application, DFMPro allows you to select and unselect each and every rule that you need to use. It also has module capability. So every rule is its own DLL, if you will, or application. And so that application then gets put into the module for, in this case, where I'm selecting additive manufacturing rules, or assembly rules, or cabling rules, or die-cast rules, and so on. You can see we have a ton of different types of rules for manufacturing processes. And of course, in here, we also have the criticality. So you can see that the ones that are checked for drilling and milling in general, some of those are flagged and those are selected as critical items. And so you can mix and match and choose. And the interesting thing about this rule manager is it's governed by subject matter experts at the organization that you're working at. And so DFMPro then gives the capability to configure these rules and then also utilize this rule manager and rule file set to be able to utilize it across an entire organization or specific groups based on naming conventions and those types of things. We've made DFMPro very extensible in that regard. And so that's basically how the rules work, from the rule manager itself. And then based on that, the information is used in conjunction with the parameters that are from the actual model or assembly. We take those parameters, we balance those parameters against the specific rules based on the manufacturing process and based on the feature type. For instance, holes would have a specific set of parameters that get pulled in. For every hole that's on this part, we create an internal array in memory, and that data is then used against each rule based on specifics like drilling or milling, depending upon the types of features that there are within the part. And so that's basically how it works. And so as you can see here, we've utilized everything about drilling. We've utilized the criticality factor that we just explained in the rule manager for critical, high, and medium. So those have been flagged. So the resultant here is information about the specific rules that have been flagged based on the parameters. And if we slide up here, I just want to show you something else too. What DFMPro does is it takes the information that's in the rule file itself, bounces it off of the features and the parameters, and then gives us not only the flag for the criticality and the actual rule itself, but it also gives us the instances. So there may be many instances on the specific part for specific items. And as you can see here, as I'm clicking on this, watch what happens. We are changing the location of the holes that are being specified here. And the reason why these instances are here is because we have violated our 8-to-1 ratio for deep hole drilling. In other words, we have a set of 8 holes that are actually deeper than the normal 8-to-1 ratio. That would be a diameter to depth ratio. And so we have gone over that, and we are at 10. And so basically that's being flagged right here in the application and telling the users that in this case here, these specific 8 holes have been flagged. And so because of the actual time here that we are allowed to create videos for the YouTube session here, I'm going to conclude, and we'll come back in and we'll start taking a look at some other information about what DFMPro has recommended in terms of criticality and parameters for the application itself. So we'll go through and we'll conclude this for now. Again, my name is Robert Olufal with HCL, primarily working in aerospace and defense analysis, and we'll have a good day. Take care.